Are we live already?
Yes. Hello, everyone. Welcome to the Python conference. The topic of this section is semantic technologies for widely diverse activities, including knowledge management, world building, and storytelling. I would like to introduce you to our speaker for this session, Alistair Kromkamp. Brad is Python and JavaScript developer, 3D AR, and the linked data technologist, creator of Contextualise. Brad, are you ready for a presentation?
I think I'm ready as we're going to ever be. Yes.
Great.
Okay, I'll start.
Okay.
Thank you, everyone, for attending this talk. As was mentioned, this talk is going to be about Python and semantic technologies. I'm going to specifically be focusing on topic maps, a specific type of semantic technology. And I'm going to try in this presentation, try to demonstrate or at least show the flexibility of topic map-based semantic technologies. And I'm going to do that by contrasting two different use cases. A very traditional use case for semantic technologies, which is knowledge management, and then perhaps a slightly less traditional use case, which is storytelling. So who am I? My name is Brett Kromkamp. I'm Dutch. I was born in Africa, in Zambia, but I'm currently living in northern Norway. I'm primarily a software developer. I identify as a software developer, but I've also been a CTO for 4 years, and I'm currently the CMO for the company I'm working for. The company I'm working for is a edtech company. I've been working in my 20 years in the IT field. I've been working a lot with semantic technologies. Again, that's the purpose and maybe the point of this presentation. The applicability of semantic technologies is vast. I've worked in the tourism industry in Spain, and there we used to manage very large CMSs using semantic technologies as the backbone. Currently, as mentioned, I'm working in the edtech sector, and there as well, we are using semantic technologies specifically for curriculum management. The national curriculum has been converted into a topic map, and we use that to manage educational content. Okay, the talk is going to be 5 or 6 parts. First of all, I'm going to focus, as mentioned, on the topic maps paradigm. After that, I will take a look at a specific use case, one of knowledge management. I will use an application that I've developed for knowledge management, personal knowledge management. It's called Contextualise. I'll use that in that use case. The next use case is storytelling. I'll get to that. And then after that, I will also show another application called STORYTELLER that exemplifies the use of topic maps for storytelling. And finally, I'll give, if we still have time, I'll give a technical overview of Contextualise and the full stack behind all of this. So topic maps. Topic maps is one of several semantic technologies. Topic maps specifically, what makes them unique is they provide a way to describe complex relationships between abstract concepts on one hand, but also connect those abstract concepts to real-world information resources. So if we look at the actual topic maps model or the topic maps paradigm, it's made up of several domain models. Obviously, it's an associative graph, or it's a graph, and specifically with regards to topic maps, it's what's called an associative graph. The models that make up the topic maps paradigm include topics, obviously. They are what represent the abstract concepts in your domain. A topic can literally be anything. Anything that makes sense within your context can be a topic. So I'm a topic, you're a topic, PyCon Sweden is a topic, anything can be a topic. Obviously, with this being a graph technology, topics in themselves, although they provide value, they also need to have the ability, or topic maps provide the ability to assert or express relationships, semantically meaningful relationships between topics. In topic map terminology, those are called associations. The next model with regards to topic maps is occurrences. So occurrences are what connect topics to information resources. So, and I'll come back to that. Finally, there are two other related models within the topic map paradigm, and that is scopes and metadata. Scopes is a very interesting capabilities that topic maps put on the table. You can think of scopes as basically a perspective or a point of view. For example, to give a practical example of how scopes are being used, as mentioned, I work in the edtech sector here in Norway. We have basically the national curriculum is a topic map. And we use, for example, scopes to indicate or to filter the topic map by level. So scopes is a perspective. And then finally, metadata. Metadata, for all intents and purposes, are key values that can be attached to any of the above mentioned models. So you can attach metadata to topics, you can attach metadata to associations, and you can attach metadata to occurrences. So as mentioned, topic maps, it's a couple of things. Topics on one hand, with associations connecting them together, expressing relationships, semantically meaningful relationships between topics. And then actually, so this is what is taking place in topic space. And then you have resource space, and that is where the actual information resources are. And this is what makes topic maps so practical, because it really is about mapping, again, abstract concepts, the relationships between these abstract concepts, but at the same time, it allows you to really establish and assert and connect also information resources to those abstract concepts. And the resource space, as you can see in this diagram, I mean, the resources can be also literally anything. So it could be a spreadsheet, it could be an image, it could be a video, or it could be anything else that is applicable to represent a topic. I'm going to take a look at the first use case, and that is actually knowledge management. For this one, I'm going to be using an application called Contextualise, and I'm going to be focusing specifically on knowledge management for personal use. Contextualise, a personal knowledge management application. It allows you to create topic maps, so you can have as many topic maps as you want, and we will take a look at this. It allows you, as mentioned, it allows you to create the topics, assert the relationships between the topics, upload and attach all kinds of information to topics, and then ultimately also navigate that resulting topic map. I will actually change now over to Contextualise, and we'll take a look at that. So you can see Contextualise, this application. It's available. It's an open source application. So if anyone's interested later on, you can check it out on GitHub. Let's have a look. So as mentioned, you can see this is after I've logged in with my user, you can see a set of topic maps that I've created. Each topic map is independent, is isolated from the other topic map, so it allows that as well. So now I've actually gone into a very specific topic maps, and within Contextualise, you're always operating within the context of a topic. So that's called the current topic, and this is important to understand. This concept is important to understand because when you are creating associations, when you're establishing relationships between other topics, you're always doing that between the current topic, the one you're in, the one you're looking at, and a destination topic. So you have a source topic, the current topic, and you have a destination topic, the one you want to assert a relationship with. So as you can see, you can attach all kinds of information to topics. For example, this topic text that you see here, that is basically an information resource behind the surface, or under the surface. What is actually happening is it's using an occurrence of type text to establish the relationship between this topic and the text resource that you're seeing here. You can attach different kinds of resources, like I mentioned. Let me navigate to a different topic. I'm going to actually navigate to a different topic. Let me just move that out of the way. I'm sorry. There, I'll go there. So here on the right-hand side, you can see topic resources. So again, this is all of the different types of resources that you can, out of the box with something like Contextualise, you can attach to topics other than text and notes. You can also attach things like images, which you can then obviously subsequently browse. You can also attach files, so upload any file type. In this case, I have a PDF. I won't click on that link, but it is just a PDF. You can also attach videos and obviously play back those videos. You can have links to other external web pages, for example. And in the case of Contextualise, you can also, and this will be relevant in the next part of my presentation, with regards to Contextualise, you can also attach actually 3D GLTF-based resources to topics as well. So on one hand, you have topics. On the other hand, you have the information resources that you can attach to topics. One of the next things then is actually establishing relationships. And here again is where topic maps go, perhaps at least out of the box, they go beyond other semantic technologies. So when you're establishing or you're asserting a relationship between two topics, you are doing that in a semantically meaningful way. So as mentioned, anything can be a topic. So if I take one of the most natural set of topics and relationships, I will take myself as a topic, a person, and I want to assert a relationship to another topic. And in this case, for example, I will assert the relationship between myself and for example, my father. So in this association, in this semantic relationship, I could say that this is an association of type family. And I could say then also that the roles that the two topics play within this association, they are also semantically defined. So I would play the role of son, and my father would obviously play the role of father. Those terms that I've just used, family, myself, and father, those are all topics. So not only am I establishing a relationship between myself and another topic, but the roles that are being used are topics, and the type of association is also a topic. So obviously this makes topic maps incredibly self-referential. Resources, associations, and then for example, just so that you can see how this manifests itself in an application like Contextualise, I will actually go to the front of the application again. And here I've created a map, and this topic map, is where I've started mapping out the Python ecosystem. So again, just a topic map. And like the vast majority of graph databases and graph technologies, you can get an actual network graph of the relationships between the connected topics. I can also use this graph to actually navigate to another topic. So if I'm currently in the Python programming language topic, I could, for example, navigate to web development here, which is another topic. And now I've navigated to that one. And if I bring up the network graph again, you would see the red one always indicates your current topic. So now I'm in the web development topic. Another interesting thing with regards to topic maps, that it enables things like what is called associative tagging. So here, for example, I have a tag, one of web. These are all of the topics that have been tagged with the web tag. But the way that this is done is it's not the usual approach. This is not the normal tagging that you would see in the vast majority of applications. What's actually happening here is also an association is created between the topic that is being tagged and the tag topic. So web is a topic, and we've established these associations by when I'm tagging something, I actually am establishing under the hood, behind the scenes, I'm actually creating, again, associations. So if I wanted to see the actual associations that have been created because I've tagged these topics, I could take a look at the associations, and here you would see all of these associations. What it's also doing is it's actually categorizing as well. So here you can see, for example, that when I start to tag topics, it's basically also creating the associations. The topics that are involved in this association, they have roles. And in this case, roles could be things like category or member, or narrower and broader. So as I'm tagging in this application, I'm also automatically categorizing inside of it. Okay. So that was basically just to give you an overview of topic maps and their use in for example, something like personal knowledge management. I will now try to contrast this very traditional use of topic maps with something slightly out of the ordinary, and that is a storytelling application. So storytelling, there is relevance to storytelling within the context of knowledge management, because we are hardwired, our brain is basically hardwired to be very receptive to stories. A lot of knowledge can be transferred, and stories have been used to transfer knowledge in the past, but even in today's world, we use stories, we connect to stories, and it's a very powerful medium to transfer knowledge. Nonetheless, semantic technologies, at least I haven't come across many examples of where semantic technologies are being used to actually model stories. So to model stories, what I've done is I basically built what I call a semantic narrative event. So there is a semantic data model for storytelling, and it consists of events. Events which map to topic maps, but it maps to a topic in a topic map. It allows you to map things to an event, like, for example, participants, place, previous events, next events. So a semantic narrative event allows you to basically say what, when, where, who, why, and how with regards to an event. Events are also recursive, so that means you can have very fine-grained events. So I can define an event in terms of other sub-events. And sub-events are to events what sub-events are to events what events are to a narrative. Events move a narrative forward, events move a story forward, but sub-events actually moves the individual event forward. So they both move the story, the narrative forward, each at their own level. This event model, this semantic event model, also has something like causal and spatial relationships. So obviously, when I'm establishing a relationship between two narrative events, I can do that in various ways, but the two most important ones being spatial, basically this place or that place, and I establish a relationship between the two locations. Or I also can establish a causal relationship, so one of cause and effect. Event A caused event B, event B caused event C, and so forth. Another interesting thing about this way of modeling, basically topic maps in many respects are what are called what I call at least a meta model. Topic maps allow you to model other models. So if we are modeling narratives on top of topic maps, it also means that I have a higher level data model, a high level semantic data model. And that high level semantic data model, that abstraction, it can be, for lack of a better word, it can be transpiled, it can be converted into a lower level semantic data model, the actual topic map data model. And this is important because then doing it this way, it means that there is an editor available. So it doesn't matter how many abstractions you build on top of topic maps, if it's always can be compiled down to or transpiled to the topic map data model, then there is an editor. So for example, Contextualise, and we will see that in a bit, Contextualise can be used then to edit a higher level data model. So here we're going to be looking at STORYTELLER. This is an actual application. It's a Three.js front-end application talking to Contextualise and TopicDB. The TopicDB is the actual topic map engine that underlies Contextualise. So this is a Three.js application that is, I'll show it, obviously. This application allows us to do a couple of things. First of all, it allows us to actually navigate interactively a 3D scene. It also allows us to interact with the 3D scene itself. So 3D scene is made up of participants, objects, so things within that scene. There are these participants and objects are obviously, you're capable to tag them as well. And at some point, there will also be AR and VR support for this. So let's take a look. So as mentioned, here you have an actual 3D scene. I can actually pan around in the scene. I can zoom in, I can zoom out. And this scene is made up of, let's have a look. If I click on this side of the screen, I can see that this scene, this specific event in the event semantic model I was just describing, this is an event. It has a place. In this case, the place is the industrial sector. It has participants, an engineer, a site foreman, and there are objects. So as I'm moving over the objects and the participants, you can see it actually, let me see if I can zoom in a bit. You can see it actually highlighting the objects or the participants in the actual scene itself. I can click on any one of these and it will actually bring up then more information about that specific object. And I can also, within the scene, I can also just click on any one of these objects and I will bring up then what is called the entity viewer for that specific object. If you think back to topic maps, basically what we're seeing here is the event is described in terms of topics. There are relationships to the participants in this event. There are relationships to the objects in this event. And there's also, and you can see the actual occurrences or the visual manifestations of these topics. And in this case, those are the models, the 3D models. I can also use this application to navigate between this specific event and its accompanying location and to another event. So here I've gone to another location event, more or less the same. If you can see that it highlights as I'm scrolling over the individual elements in the scene, it highlights in the scene the actual accompanying object or participant. I've also got tags in the scene, so different objects have been tagged, again, using the associative tags that I described earlier. Sorry, let me just bring up my time. So here you can see, for example, that if I click on building or if I scroll over, if I hover over building, it will actually highlight the two buildings in this scene. And if I do that with colonist, it will do that for obviously the two colonists, the two participants in this scene. And if I hover over transportation, then it will actually show the object that has been tagged with transportation. I can click on this and it will obviously bring up the appropriate information about that tag. Again, these are just topics with occurrences and associations. Finally, what this application also allows you to do, as mentioned, I can have sub-events. Sorry, I can have sub-events. So here you can see that in this main event, there is a sub-event, and that sub-event is, in this case, it's called rocket assembly. So if I click on that, it will actually zoom in and show the actual sub-event itself. Just to make clear, the models used in this are static, but they could have been animated as well. And then finally, what we're seeing here is this navigation to previous and next events. This is an example of a causal relationship between events. If you look at paths here, that is an example actually of a spatial relationship between events, just a distinction. So here, finally, you can see the full colony. This is a space colony. And you can see it can display all of the labels for the objects in the scene. I can obviously, just like in the previous scenes, in the previous events, I can interact with any one of these objects and it will bring up the appropriate information about that object. What you should take away from this is that it's basically, again, it's using a semantic events model, but that is ultimately being compiled down or transpiled down to the topic map model. So for all intents and purposes, these are topics, these are occurrences, i.e. information resources, and these are relationships between the different entities. So between scenes, between events, between the participants, and between the objects. They are associations. I will actually show what you're seeing here. I will actually show how this looks in Contextualise. So again, as I mentioned, this basically is compiled down to a topic map data model as well. So everything you're seeing here is visible, is available in Contextualise because it's a topic map editor. So this is the actual map that I used to create, or that was used to actually model what you've just seen in Storyteller. So that very first scene, it was called, the very first event, it was called the industrial sector. So here you can see on the right-hand side, I'm hoping people can see it. Let me just increase. On the right-hand side, you can see all of the related topics. So when I was in that industrial sector event, the actual associations that were available to that event or part of that event are these. So here you can see a spatial navigation association that would take you to the research sector, the next event. And there's also a temporal navigation relationship, which also would take you to the research and tech sector. Then there is the industrial sector itself. So this is actually to ensure that the scene is displayed for the event. So if I go to that topic, you can see now I'm in the industrial sector topic, and I can actually bring up the associated occurrence for that topic. So yeah, you can see, just like you did in the storytelling application, here you can see this occurrence that is connected to that topic. And then things and participants. So again, if you think back to that industrial event, the industrial sector event, it had certain things that were part of that event, including things like the monorail, the reconnaissance aircraft, the personnel offices. There were several buildings, all part of that scene. And there were also two participants in that scene, the site foreman and the engineer. And they are all available here. Again, all of these are topics. So if I actually navigate to this topic, I can not only see the information with regards to this topic, I could obviously edit this topic, and then I can also see things like the occurrences for this topic. So this would be then the actual engineer model. So again, this is just an example of an information resource. So what I hope I've been able to do, at least up until now in this presentation, is contrast or display the flexibility, exemplify the flexibility, the different use cases where semantic technologies in general, but specifically topic maps, can be used. So if we looked at a very traditional use case, one of knowledge management, and then we looked at another use case, and that was storytelling. Two quite different use cases. But in many respects, everything is a graph, so completely expressible using something like topic maps. Finally, I'll take a look at, this is a Python conference, so let's have a look at the underlying technology. Contextualise is a Flask application. There's reasons why it was a Flask application. Obviously, in the Python world, there are two really major web frameworks, Flask on one hand, Django on the other hand. There's a reason why I chose Flask instead of Django to actually implement Contextualise, and I'll get to that. Flask, as I'm assuming the vast majority of people watching this conference, this talk, they're aware of what Flask is. It's a so-called micro framework, but it's very scalable in the sense that by means of its capabilities, like, for example, blueprints, you can go from a very simple application, one of these one-file applications, all the way up to a relatively complex application like Contextualise. Another important aspect of Flask is that it's very unopinionated, and that was very, very important in the context of implementing an application like Contextualise. The difference in many respects between Django and Flask is that Django has a lot of, I think Django says batteries included. And specifically, one of the bigger and better batteries of Django is its ORM. It's making a lot of assumptions that you are going to be using its ORM. And that's exactly why you would use something like Django, because of its ORM. In this case, Contextualise in itself, it doesn't actually have a straightforward data model. It's not the usual data model that you would think of, relational data model. It's actually got a graph data model. And the application or the library that actually exposes or enables this functionality, the topic map engine, as it's called, is TopicDB. So I needed basically an application, or sorry, a web framework that would allow me to plug in, wire up a backend that is not a usual backend. And Flask just makes that very easy to do so. Some information with regards to TopicDB, the underlying topic map engine. So in many respects, Contextualise, the application I've just shown you, it's a front-end web application. I call it front-end. I don't mean a JavaScript front-end application. It is obviously a server-side application using Flask, but in many respects, it is a front-end application, and it talks to a backend, and that backend being the actual topic map engine, the TopicDB library in this case. TopicDB is very much what is called a repository. So it's very much using one of these enterprise patterns, the so-called repository pattern. Wiring up and using this topic map engine in Flask and by extension also Contextualise, it's very, very straightforward. And I mean, in this case, it's actually described in the Flask documentation. One of the sections in the Flask documentation is connecting to your database. So basically, what you need to be doing is you have a method, and in my case, that is getTopicStore. Where you can, at any point in your blueprints, you can normally at the beginning of a method, a root in a blueprint, I say, get me the topic store, and then from that point onwards, it's open. The topic store is open for me to be able to operate on the topic store. And then obviously once the request has come to an end, or just before it comes to an end, it actually needs to close the topic store. So the connections are then closed, because ultimately the topic store is backing off to another store, and that in this case is PostgreSQL. So yeah, you can see how to wire up the data store in something like Flask. You've got an init_app method, and there you basically register so that it actually, at the end of the request, it actually does this app.teardown_app context. That is what would close the data store, and by extension, close the connections to the data store. And when I'm saying data store, I'm basically saying the topic map engine. Here you can see this is just some example code with regards to how you would actually, in a Flask route, in a Flask method inside of a blueprint, you would how this all looks. Here you can see right at the beginning of the method, I actually call that topic store equals get topic store. That now gives me an open topic store. I can then do whatever I need to be doing on that topic store. I normally start off by opening, by getting the actual topic map, the relevant topic map, and then from that point onwards, there's some boilerplate here to ensure that you are allowed to do what you are doing in this topic, in this specific topic map. And then from that point onwards, you are using basically the topic maps, the topic map engine's API. So this is again things like get topic, create topic, get occurrences on the topic, create an association between this topic and that topic. And then once you've completed the request, the topic store is then closed up again. Thanks, and any questions? I mean, that was a whirlwind, but the point, what I've tried, and I hope I have been able to do, was actually, in many respects, semantic technologies are so extremely versatile that they can be used in all kinds of contexts. Hence, that's why I try to contrast a very typical use case, knowledge management, with a somewhat, I believe, a somewhat not so typical use case, and in this case, storytelling. Topic maps specifically allow you to do this. Topic maps, because they are again a meta model, you can build all kinds of abstract data models on top of a topic map that would ultimately then transpile or compile down to topic maps again. So the flexibility there to model your data models, your content data models, or data models just in general, and have them ultimately expressed as topic maps, it opens up a lot of possibilities. And because ultimately it is always a topic map, if you have a topic map editor, like in this case Contextualise, it doesn't matter what level of abstraction you are using. Ultimately, you can always have an editor available to you to actually edit that data model. So again, I hope I was able to express the flexibility, how applicable topic maps specifically are, or semantic technologies are. And I'm hoping that people see these opportunities and basically run with them. Okay, I think I've ended slightly early. I'm not sure, but if there's any questions, or if you want me to go back and show anything, then by all means we can do so.
Yes, thank you, Brad, for your presentation. It was really good, and thanks to our audience for listening. I think they can ask some questions on the chat in Slack. So then we are finished, and you can connect to the next presentation.
Okay, do I have to do anything, Valeria?
No, that's fine.
Thank you very much. Again, if there's any questions, then I'll be available.
Good. Goodbye.
Thank you. Bye.